Assalamualaikum and welcome to the part 2 of this series where I am actually discussing different algorithm development in C language. And in the last part, we did the Floyd's triangle, which was this triangle, if you remember it. And we developed the whole algorithm. We discussed how nested for loops were actually going to be used over there. We took the generic case of n equal to 5. I showed you about the rows and how the outer loop is actually going to cater the rows over there, and inside one row how it's actually going to be displayed is actually going to be the inner loop, which is actually going to be the nested for loop over there. And then we developed the whole code as well, and this was the final code as well. And then we ran the code for this table as well, and it was displayed for n equal to 3. You can extend it for n equal to 5 as well. Now there's a slight variation in all this which can be done, that a Floyd's triangle, instead of having this consecutive 1 2 3 4 5 6 up to so on, whatever the number of rows you have, depending upon it, it can also be done with the case of number of rows having 10101010. Now when you are going to do something like this over there, then certainly this means that there is certainly going to be some change in the code over there. And that code, for example, if this was the code over there, so let me just take this code, so just going through it, and then afterwards I'm going to go towards the Fibonacci series over there. So if you have something like this and you want to actually do it a new one supposedly, and in that case let me just add it over there in a new page. So if you have something like this, so in that case your number which is actually going to be printed is actually not just 1 2 3, it's actually 1 then 0 then 1 then 0 then 1 then 0, and then it's going to be 1 0 1 0 and so on. It's going to go on up till like this. So this means you are actually toggling your number. So this means actually that now there are two ways to do it. One is by using an integer, and you are actually going to change every time an integer is going to be printed, or the other way is by using a boolean. So this is one way, or the other way you can do it. Now we'll just show you how you are actually going to do it with this one. Now supposedly this was the initial code over there. So supposedly you have an integer, and that integer is print underscore number. So if you have integer underscore print underscore number, you are going to initialize it to supposedly 1. Now when you have initialized it to 1, now you are not going to increment it. So this time you're not going to increment it over here like this. So it's going to be based on some if else condition, and you are actually going to do something like this. Let me just make this a little down so I can add those if else statements, all that over here. So inside this internal for loop over there, you will be actually, first of all, after printing that whatever that number is, 1 or 0 or whatever, you are have to change it to 0. So this means that you are going to have an if else condition. If print sorry, this will be p actually, so this will be print underscore number is going to be equal to, now if this is equal to 1, then what it's going to do, I don't need the braces or any brackets over there, because it's just going to be one kind, so one line. So print underscore number will become equal to 0. Else if print underscore number is equal to 0, then print underscore number is going to be equal to 1. That's all. So you're just going to have this 2 3 statements over there. That is actually an if else statement over there. In fact, you even don't need this thing over there, because it's going to toggle between 1 and 0. So you don't even need this if statement over there. You can just have the else and just written down print underscore number equal to 1, and this will straight away now going to give you, if you're going to have n equal to 4, you're going to have something like this. And then of course this will be 1 0 1 0 1, and this will be going to so on. So you can display something like this, that is going to actually have a Floyd triangle, but this time it will be having a little different way, and that will be a Floyd's triangle over there. And that Floyd's triangle will be based on very simply, let me just show you the code over here. The code is actually the most important thing, and that actually code is going to be displaying you the if else statements, and I'm just trying to find out that code over here. Yes, this one. So let me just share this code over here so I can actually show you here. So this code is actually going to be something like this, and this is the code here in front of you. You can see very easily here the simple code over there, again verified from your Visual Studio Code. You can see int n is equal to number. You have int number here instead of number print underscore number. I have just simple number over there. You can see over there, and you have the for int I is equal to 1, and then j is equal to 1, and you have again same thing doing up over there. So here this is the if else statement. You can see if n number is equal to 1, then it changes to 0, else it's only going to change to 1, and then the whole statement. So this is exactly the same, just like the statement. And let me just, if I want to actually show you side by side these all, so the code changes to something like, I'm just going to try to show you the code over here. Yes, this is the code. So the code is exactly the same, just like I have shown you here. So this is actually the Floyd's triangle with 1 and 0 over there. So this is again same Floyd's triangle, and you can see this can be displayed, and you can try to run this one from this one. Okay, now going on towards the next, which is actually the main basic thing of today's lecture, or this part, is actually the Fibonacci series. And a Fibonacci series is a number where each number is the sum of the two preceding numbers, which means the two first elements of this thing are going to be fixed, which means that they are going to be 0 and 1. So let me just show you what is a Fibonacci series over there. A Fibonacci series, if I just show you over here, a Fibonacci series is something having the sequence something like this over there. So if you see over there, this thing, it is a Fibonacci sequence, and you can see very easily in this Fibonacci sequence over there, the first two numbers are default, which is 0 and 1, and then it's also called a Fibonacci number. You can call it as a Fibonacci sequence as well, so it's totally up to you whatever you want to call it. But again, since it's a sequence and it's increasing, so after 0 and 1, you add these two, you get the third number. So when you get the third number, then you add this and this, then you get the other number. Then you get the latest two numbers, and then you add them, and then you get 3. Then you add the latest two numbers, and then you get the next one. And then after again adding the last two ones, you get the other one. And then you can go on. And this can go on depending upon how many numbers of terms you want. Like supposedly in this Fibonacci series, you can see very easily over there that this is 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 Fibonacci series over there in this sequence. So if you see very closely and how you are going to actually develop the algorithm for this one, the algorithm for this one is going to be based on 3 numbers. What are those 3 numbers? These two are default, of course. The third one is going to be made because of the sum of the two numbers. So this means that practically whenever I'm going to talk about this development of this variable or this Fibonacci sequence, then this means, let's say I have 3 variables. I'm not going to make a pseudocode at present. I'm just going to tell you how you are going to do it. You have one variable which is called as x0, one variable which is going to be called as x1, and another variable which is going to be called as x2. Now, this is going to be 3 variables, of course, integers, initialized. And since by default, Fibonacci sequence has 0 and 1, so this means x0 will be initially 0, x1 will be equal to 1. Well and good, no issues, first class done. Now, x2 will be equal to x0 plus x1 every time. So this is the third number in the sequence. So you are going to add these two together. So this will be 0 plus 1, and this will be equal to 1. So x2 will be equal to 1. Now when you have got this third number over there, now when you have got this third number and at the same time you have printed the sequence over there, let's suppose you have printed x0, then you have printed a space, of course, and then you have printed 1, then you have printed the first two numbers. Now you need to print the third number. Now you need to print the third number over there. So this means that now you are going to have x2 printed over there. So after the initial two numbers, remember, if the number of Fibonacci sequence you are going to ask from the user, if it is just equal to 2, this means you are just going to print 1, 0 and 1. But if the user is telling you that you have to write down 3 Fibonacci terms over there or sequence terms over there, then this means, so this means practically x2 is going to be printed if it's going to be the third term asked. So this time x2 will be printed over there and this will be 3 over there. Now after this process is gone, supposedly this loop has finished over there, remember this is going to be just one single loop over there. When all this process is done over there and all this thing has been done, now what you will do over there, now see this very carefully, when x2 is there, now since we know x2 is equal to x0 plus x1, so we have to now change the values of x0 and x1. So what was x0 will now be the constituents of x1. So this means previously, let me just again write it, previously x0 was equal to 0, x1 was equal to 1, x2 is equal to 1, which is actually the sum of these three. Now when the next iteration comes, supposedly in the next iteration, what will happen, your x0 will become equal to 1. Why? Because it's going to take the value from x1, okay, and x1 will be becoming, let me just use the same color so it's actually become easy, and x1 will become equal to 1, which is going to be the value taken from x2. So what is this happening? You are actually taking the values from the previous numbers, and now x2 is going to be calculated again by x0 plus x1, and that will be equal to 2. Now when this is done, let me just take this whole figure and let me just put this one here. Let's just say this is 1. Now when this is done, I have the next iteration in front of me. Now when this is done, 2 will be printed over here. So now next thing, x0 will now be taking the value from x1. And what is x1? x1 is 1 over there. So this means you are actually taking the value from here to here, and then you have the x1 equal to x2. And what is x2 over there? x2 is coming on from here, which is equal to 2. So this time this will be equal to 2, and now x2 will be equal to 1 plus 2, this will be 3. So again the one iteration will be complete, and now this time x0 will be equal to, this will be taking it from here, that will be 2, x1 will be equal to 3, and now x2 will be equal to the sum of 2 plus 3, this will be 5. And again these values are coming on from here and here, and then the next iteration will start over there, and you have x0 equal to, this will be coming on to 3, this will be x1 equal to 5, and x2 will be equal to 8. So now, and this process can go on. Remember, this process can go on, and you are going to now have after 2, remember, you are always printing x2. Remember, you are always printing x2. 1, 2, 3, 5, 8. So 1, 2, and this will be 3, 5, 8. Remember one thing, the first two numbers are fixed. They will never change. They are always fixed. They are going to be always by default fixed over there. That's what the word default is there. And how many number of terms you want to print, that is the point where you are actually going to run your for loop, which means here, let's say I have a variable. Let me just add another variable over there. Let me use another color. So I have a variable. Let's say I have asked the user that enter how many terms you want. Enter the number of terms of the Fibonacci sequence. So Fibonacci sequence, and you have it, and you store it in n. So let's supposedly the user has entered 5. So at this point n is equal to 1, at this point n is equal to 2, at this point n is equal to 3, at this point n is equal to 4, at this point n is equal to 5, and if you go on, this will be n is equal to 6, and so on. So if the user has entered n equal to 5, you are going to display just these numbers over there, that is 1, 2, 3, 4, 5. So this will be over here, you are going to have displayed over there 5 numbers over there. So now to make this command work very importantly. Now I'm going to develop the code here. I have just developed the algorithm in front of you, that how this is going to actually proceed. Now going on to make the algorithm. Now for that algorithm, of course, first of all, you have to initialize n over there, which is the number of terms over there, which is actually the number of, the first thing, it will be number of terms over there, and that number of terms will be n, and that is the user is going to input it. Remember, this is going to be the user going to input, and of course this is going to be by scanf and all that stuff over there, so that will be already there. The next thing, you are going to declare and initialize three variables, x0, x1 and x2. And at the very same time, when you are declaring this, x0 will be stored as 0, x1 will be stored as 1, and x2 will be stored as 0. I've still not done the summing of this one because that will be done inside the for loop. Now when you have done it, you have taken it, let's say, let me just make this a little down and make this one as the third one. Sorry about the color, miss the color. And you have taken the scanf command, and the input is being stored inside the n, which is being done over there. So you are taking the number of terms being input over there. Now after this thing, the fourth thing which you are going to do, of course, you are going to start the for loop over there. Now I'm just going to write down the for loop over there. So we have the for loop here. You will start with int. Let's say you have x, or not, you can't use x actually because that will confuse you over there. So I'm just going to use I over there. So int I is equal to 0. Then I is less than n. Why? Because if n is equal to, like, supposedly 5, so starting from 0, 1, 2, 3, 4, there will be 5 terms. If you start from 1, then you have to put that equal to also with this, but I'm starting with 0 just to give you a little different flavor from the previous part. So this will be I plus plus over there. This is the first term. So after, and this is not going to be nested loop. Remember, this is not on just 2 different lines. It's just a repetition of the run. Now, after this for loop is started, now, as you all know, the first 2 parts or the first 2 sequences are fixed, or the first 2 terms of a Fibonacci series are fixed, which is 0 and 1. So this means that if I is equal to 0 and 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is the number of terms over there. This is that variable I. So this means if I is equal to 0 and 1, you just have to print x2 over there, which means that here inside it, let me just change the color so it's a little easy. So if I is less than or equal to 1, okay, then you are just going to have x2 equal to I. This is very simple. X2 is equal to I. Now, when I is going to be equal to 0, x2 will be equal to 0. When the next 2 will start, I is still equal to 1, then x2 will become 1. So now you just have to print x2 at the very end, and when this is done, you have else condition. Now when else is there, you don't need any if else statement over there, just you need to have the braces open, and inside it, now here is the actual term, you are just going to have x2 equal to x0 plus x1, and x1 or x0 first of all, because x0 is going to be equal to x1 and x1 is going to be equal to x2. This is exactly the same thing which you have been doing in the last thing. Taking the value of x1, storing in x0, taking the value of x2, storing in x1. And this is exactly the same thing, taking the value of x1, storing in x0, taking the value of x2 and storing in it. And at the very same time, x2 is equal to x0 plus x1. You have to do that sum first. This is very important because you are having this term over here. So when you have x2 equal to x0 plus x1, and when you have done this one, very simply close this one, and after this else statement, after this thing, because when the loop is running, for the very first 2 times, you need x2 equal to this value. Then afterwards, when that I has increased from 0 and 1 and then had gone to 2 over there, then you need this part to work because the first 2 terms are 0 and 1. So here you are going to just print f and it will be percentage d, and it will be x2. That's all. And you can now close your let's say the loop over there. I'm on the other page over there, and here then you can just return 0 or whatever stuff over there, and this will straight away. Now just to verify that this will is going to work or not, now let's see over there. Initially, supposingly you have n, you have I, let's say you have n and I over there, and you have x2 over there. Okay, you have three terms over there, and at this time, supposedly the user has entered over there n equal to supposedly 4. So n has entered. Now when the loop starts, I is equal to 0. So the first time I is less than this condition, I is less than 1, of course, because I is 0. So this time x2 is going to be 1. So x2 is going to be just equal to I. So this will be 0 printed over there. So what is going to be printed over there? That will be just because x2 is going to be printed over there, that is going to be 0. The next iteration happens, n is not going to change, n is still the very same. I is now increased to 1, but still again this term, this one is going to be running over there because I is still less than or equal to 1. So this time now x2 will be equal to 1, and that will be printed. Now this time the next loop starts over there because this condition else was not run. Then you go to n is equal to 4. Now this becomes equal to 2 over there. Now 2 is now not less than 1, so this portion is not going to run. Now it's going to go inside this else, and now x2 will become equal to x0 plus x1. What was x0? X0 was equal to 0, x1 was 1. So now this term will become equal to 2. Oh, sorry, 1, not sorry, 2. It will be 1 over there because 0 plus 1 is equal to 1 over there. So now when you have done it, now you change x0 and x1. You have now 1 and 1 inside it. Now the next loop starts over there. In the next loop, you have 4 over there, and now you have 3 over there. Now 3 is still inside the loop. It is still less than that one. So you have now 1 plus 1, 2 printed because this condition will be run first, and then you will having the swapping the values of x0 and x1 and storing them, and then it will go up. No, it will not go up because now I has reached its maximum, because now this time it will increase 3 to 4, but this time this condition will be violated, so it will up. Now here, if n was equal to 5, then it will go for one more time. If n was equal to 6, then it will go more time. Here n was equal to 4, so your loop will stop here. And at this particular time, the Fibonacci sequence being printed by this line will be equal to 0, 1, 1, 2, which is exactly the same thing as shown over here, 0, 1, 1, and 2. Over there. And just to give you the whole code in front of you, I have this code over here with me, and just to show you this code over here, and this code is on this portion. I have this one, and this is that code. Exactly same thing over here. You can see very easily that over here int n is equal to 0, x2 not is equal to x0 is equal to 0, x1 is equal to 1, and x2 is equal to 0. Enter the number of terms. You're having the printf statement and then a little bit statement, just to give you an idea that it's a Fibonacci series over there, and you can run it and you can easily get. So this is just a simple for loop and if else statements being used to have this one. And I can show this code over here. Let me just add this code over there on this portion, and let me just add this one. Where is that code? Actually this is that code. So this is that code. So you can see very easily now in this code or in this line, this portion is going to be run for just the first 2 times the loop is run, and this one is going to be run when the remaining times when that loop is going to be run over there. So depending upon the number of n which you have entered over there, so if n is equal to 5, so this means 2 will be here, 3 will be here. If n is equal to supposedly 6 over there, then it will be 6 over there. So 2 times this portion will be running, and then for the remaining times this will be running over there. So this can have a long number of Fibonacci sequence being printed over there, and you can see very easily over there. Now one challenging task, not actually a challenging task, just incorporating it, that someone may ask you that instead of having this sequence printed in a Floyd triangle, print a Fibonacci sequence. So Fibonacci sequence inside a Floyd triangle. This is something a little easy as well, but you just have to add the sequence how this is being printed over there, and you can add. So this means that this will be 0, this will be 1, this will be 1, then this will be 2, this will be 3, this will be 5, this will be 8, this will be 13, and so on. So you can do that one. Take this as a task and this will be very easy for you. So this is the Fibonacci sequence being printed over there, and this is the code in front of you which you can easily use for the Fibonacci series. I hope you like it. Thank you.